Hello there, Wildcats. Welcome to your Algebra 1 class. In this video, we are going to study about scatter plots and line of fits, and then we're going to analyze them, your the best line of fits. So our objective is that we have to use a scatter plot to describe the relationship between the two data set, and also we also have to in analyzing line of fits, we have find the lines of best fit for a data set and evaluate its goodness of fit. So there are certain time that the linear function will not form a straight line. So we will now incorporate that. We will now going to analyze those graph using linear function. Okay, so I have here three graph, and then how is this related to the to your scatter plot, and we're going to understand the what we call now association of this point. All right, so one of the common error is that you may think that since the points do not lie since the point do not line up, okay, exactly, there is no relationship. However, okay, when looking for an association, you are looking for a general trend. Okay, even if they don't form a straight line, what you are looking at, it's the general trend. Okay, so let's start with letter A. It says there, what is the relationship between the hours after sunrise, X, and the temperature Y shown in the scatter plot? So as you can see here, it doesn't make any straight line. Okay, so the temperature is generally increasing over time. So based on the graph, as you can see here, it's increasing. Okay, as number of hours after sunrise, so does the temperature when y values tend to increase as x values increases. So that is now the relationship between your x and y. The two data set have a positive association. So if I'm going to draw a straight line here, maybe I'll just use blue. So from here, you see the graph there. So if you relate that to slope, so your slope is like uphill, it's a positive slope, then this one has a positive association. Okay, now how about letter B? So if I'm going to draw a line, so from here, okay, this is hypothetical, I'm drawing it a line. So when you are going to analyze this one for letter B, as the number of hours after sunset increases, the temperature also decreases. Okay, when y value tends to decrease as x, so both of them are decreasing, the two data set have a negative association. Okay, now the last one, maybe I'll just give you another common error on letter B. You may think that negative association means that there is no association between the data sets. However, the word negative describes the direction of the relationship. Okay, again, the word negative there describes the relation or the direction of the relationship. Okay, next is your letter C. What is the relationship between the hours of sunset X and the amount of rain Y shown in scatter plot? As you can see there, there is no relation. There is no relationship, okay, between the amount of rainfall and the number of hours after sunset. So when there is no general relationship, okay, between the X value and the Y value, okay, there's no relationship, then no association. So those are the three trends that we are looking at. Okay, So positive association, negative association, and no association at all. Meaning I think there is not related on the values of x and the values of y. So you are comparing different variables and no association. Right. Next is we have this example. What trend, okay, what trend line models the data in this scatter plot? Okay. When we say trend line, it models the data in a scatter plot by showing the general direction of the data. A trend line fits the data as closely, okay, as closely as possible. Okay. Now, if I'm going to draw from here, let's check that. So if I'm going to draw a line here or array, so from here, and then I'm going to do maybe until here, there. So I'm going to put this one as a point here. So look at that point here. This is sorry about that. So the point here, so this point is 16, located at 16,500. Okay, so we are going to look for the trend line. Okay, so we did sketch the trend line for the data, so that's the step one. Step two is write an equation of the trend line. So we are going to write an equation. First is we have to get the slope. Okay, so the slope is m is equal to, I'm going to use 600, 500, this one minus, maybe I'll just get this here. Maybe this one is 2 and 50. So this point here, this is 2 and 50. So I'll be using that. So any point, as long as you can use and find the slope. So 500 minus 50, divide this one by 16 minus 2, wherein my m is equal to 32.1, or I'll put there approximately 32.1. So that is my slope. So use the slope to write an equation using slope-intercept form. So I have y minus 50 is equal to 32.1 x minus 2. So I have y is equal now to 32.1 x minus 14.2. So this is now our equation. Mr., how did you get that? I distribute this one, and then after distributing, I subtract 50 both sides. All right. So the trend line models the data in y is equal to 32.1x minus 14.2. So this is the trend line in one of many possible trend lines. Okay, this is just only one of them. Okay, so you can draw any of this that will again, it's closely as possible. Right. Next example. So the table shows the amount of time required to download a 100 megabytes file for a various internet speeds. Assuming that the trend continues, how long would it take to download the 100 megabyte file if the internet speed is 75 kilobyte per second? So this is now the table. So your step one here is I'm going to make a graph. So let's say I'm going to make a graph here. So I'll be using blue. I'll just make I'm going to make a simple graph here so that you will see how does it um, let's just visualize how does it look like. So on here, down here, I'm going to use of course this is 0, and then I'll just count by 20, 40, and we have 80, we have 100, and then here maybe this is 3, 4, 5, 6, and then 7. Let's just put there. This is your y, this is your x, this is your internet speed, and this one will be your time to download in minutes. Okay, time to download in minutes. Now, we have to graph that, and then we'll just put the scatter plot here, 6.65. So 6.65 and then 35. Maybe it's here. I'm just plotting it. Where is it? Like where is it located? And then 5.82, which is 40. It's here. Okay. And then we have 45, 5.17, and 45, which is also here. Maybe let's just estimate that. And then 4.65 and 50, which is somewhere here. Maybe I'm just a little bit close here with 50. And then we have 4.23, and then that's 55, close to, maybe let's just have to estimate that, which is close to, and then 63 point. I'll just change this one. Just put there, and then this is 80, this is 100, and then I'm going to put 60 here. It's pretty much near to your 80, so it's not a straight line. Okay, and then let's draw a line. I'm going to draw a line here. Best fit it as close as possible. Okay, and then the next one is I'm going to make a selection of 2 points. So my point would be maybe 40 and 6. Okay, 40 and 6, it's this one, so I'll be using red. So 40 and 6, I'm going to use 40 and 6, and then the other one would be 55 and 4. So let's just put that there, 40, 55, and 4. So 55 and 4. So I'm using the red one, which is these are the point that is exactly on your line. So step 2 is you find the slope. Okay, so m is equal now to 6 minus 4 divided by 40 minus 55, which is basically, as you can see, it's going down, so it's negative. So it's negative 2 over 15, which is approximately negative 0.13. So that is your slope. So next step is we're going to make an equation using 1 point and the slope. So we have y minus 6 is equal to negative 0.13 x minus 40. That will give me y is equal now to negative 0.13x plus 11.2. Okay, the download now based on the this is our equation. Now I'm going to plug in 75 to the value of x. So I have y is equal to negative 0.13 times, okay, times 75 plus 11.2. So the download here, if you will be using your computation, we have y is equal to 1.45. So to interpret that, we can say that the download, so the download time would be 1.45 second. So first, the first step there is you have to plot the point, and then you have to make a straight line on your graph, and then make sure that that straight line is the closest that you can make from the point. And then once you are done making a straight line, I want you to select 2 points on the line, okay, not the 2 points that is scattered. So 2 points on the line. That's why I use red here. I didn't use any of the points that I graphed. 2 points on the line, and then use that to get the slope of the line that you have there, that you draw. And then using that, you have to make an equation in the form y is equal to mx plus b, using 2 point slope, 2 point. And then after that, you can just go over with the problem. What does it say there? Does it asking you to just write an equation, or does it give you does it asking you to find for something else, just like this one? All right, so the next one is we are going to analyze. Okay, we're going to analyze lines of feet. Okay, that means that we're going to analyze what does this scatter plot is telling us. Okay, the first part here is that we are going to find the line of best fit, and we are going to of course we'll be using table again. Now let's proceed with this first example. What is the equation of a line of best fit for the data in the table? So this is the table, okay? And I want to define what is a linear regression. So a linear regression is a method used to calculate the line best of fit. A line of best fit is the trend line that most closely matches. Again, it's closely matches the data. Okay, it's not a straight line, but we need to make at least the closest line that we can do on this one. All right, so the first thing that I want you to do is I'm going to grab my calculator here. So make sure that you have your calculator with you guys. All right, let's see. There you go. Where's my calculator? Here. So first things first is I want you to use your calculator, and then maybe I'll just put it here. I want you to make use of that by putting this number here. So we'll do it one by one. So first, or step by step, okay? So first is I want you to press Tab, and then you have choices here: edit, sort A, sort D, clear list, setup editor. And then the first one is you have to press 1, and it will give you it will give you line 1 and line 2, meaning the value of x and the value of y. So I put it here, okay? So 1, 2, 3. So 1, 2, 5, 8, 9, and 17. So we'll just put 1 and then enter, okay? And then you have so 1 and then enter, and then you have 2 and then enter, and then 5 and then enter. We have 8, enter, 9, enter, and then 17. So you put 17 and then enter. Once you are done, I want you to press this arrow key here. It will go on the second line, just put it there, 30, 55. So 30, enter. You have 55, enter. 75, enter. 120, enter. And then we also have 145, enter, and then 250, and then enter. Okay, once you are done, I want you to press again stat. Okay, now you see here edit, calc, and then test. So I want you to go, you go to calc, and then you go down until you see reg. You see this one? LN regression. So it's linear regression. And then I want you to click enter once you see the black here. So I want you to enter, and it will give you line 1, line 2, and then you just go enter, 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 enter. Then it's blinking on calculate, so you just put enter there. So this is now your linear regression on this part. This is now your linear regression as the basic. Now, I want you to move into the more detail of the linear regression. How to do that? I want you to go to stat, and then instead of calc, you go test. Okay. Once you reach test, I want you to go down, and you will see here linear test, linear regression test. So there, it's letter F. So letter F, and just enter. Again, you do the same, enter, enter, until you will reach your calculate there. So go down and then calculate. So it will give you this table. Okay. Now, because this table, we have your A is 17.58 or 59, B is 13.55, and then do you have more there? Yeah. R squared is 0.99, and then R is 0.995. What else we have there? There. So I'm going to show you what to do. So your A here, okay, you see this A, which is 17 point. So your A, I'm sorry about that. Your A, this is your y-intercept, and your B, that is your slope, right? So based on that, I can now have, based on that calculator that I have there, so I can now write the equation, which is y is equal to 13.56x plus my y-intercept, which is 17.59. So the equation of the line of best fit for the data is this: y is equal to 13.56x plus 17.59. So that is how you use your calculator there. All right, so the next one is there. So the next one, I just want to emphasize this one, okay? So your in your calculator, this will be this is B, okay, and this is A. So they use the different calculator, so they interchange. That's why I'm analyzing it a while ago. All right, so what does the correlation coefficient reveal about the quantities in the bivariate data set? When you perform a linear regression using technology, you are also given the correlation coefficient. When we say correlation coefficient, this is represented by the letter R, small letter R. This is a number from -1 and 1 that indicates the direction and the strength of the linear relation between two quantitative variables in a bivariate data set, a set of data that uses variable. Now, if you go back on your calculator, I'll just put it back here. So you will see here there's a r squared, and then you have r, which is 0.99 and 0.99, almost 1. So let's analyze that using this one. So when the correlation coefficient is close to 1, okay, there is a strong positive correlation between the two variable, that is as the value of x increases, so that the values of y also. So in our example, the r is 0.9995, so it is a strong positive relation. However, if when the correlation coefficient is close to -1, there is a strong negative. So let us say if that is negative 0.999, close to -1, it is a negative correlation. Okay. And if it is the coefficient is close to 0, there is a weak correlation between the two variable. Maybe you can say that there's no relation, or there's no association to that. Example, we have negative 0.284, or yeah, as long as it's close to 0. So there are three. So close to 1, close to -1, and then close to 0. Right? So that's how you use your calculator, guys. All right, next example, the concept of residual, meaning it is when you say residual, is the difference between the y value of the data point and the corresponding y value from the line of best fit. Because what we have is that we have the exact line, okay, which is what we call now the line of best fit, and then we get the difference between the projected y value. So the residual is using the equation, the actual value of y minus the predicted y value. Okay, so as is, a residual plot shows how well is the linear model fits the data set. If the residual are randomly distributed on either side of the x-axis and the cluster close to x-axis, then the linear model is likely a good fit. So we'll discuss that in our next example. How are we going to solve a residual, and how are we going to interpret that? All right. So we'll do this one, an example for that here. Now, student enrollment at the Blue Sky Flight School over 8 years is shown here. The owner used linear regression to determine the line best fit. The equation of the line best fit is, okay, we need this equation. Okay. Now, this is the predicted, okay, year. This is the year, and this is what the owners are predicted number of students. Okay, how well does this linear model fit the data? First is this is we have to use this equation because this is the not the predicted, sorry, it is the number of enrollment based on the owners based on the owner, okay, because of the owner use a linear regression in here. So if I'm going to plug in 0 to my equation, y is equal to -35x plus 1208. So if this is if x is 0, then the y is 1208. So we are now plugging in. So if you can use your calculator, I want you to just change the value of x with 1, 2, 3, 4, 5, 6, and 7. So if I'm going to plug in 1 to my x, the answer here is 1173. So we have 1173. There. If you plug in the value of x from here, so if I plug in 1, it will give me 1173. If I plug in 2 to that x, I got 1138, 1103, for 3, and then for 4, if I plug in 4 on the value of x, that's 1068. If I plug in 5, it will give me 1033. If I plug in 6, it will give me 998, and if I plug in 7 for the 7th year, it give me 963. Now, so as you can see, the difference between student Y and then the predicted value, which is the exact value based on the equation that is given there. Now, what you do for the residual is you just subtract this two. Okay, if I'm going to subtract that, what will give me here will give me 27. Okay, and then it gives me 5 here, and then you do the same there. So the residual is when we subtract the student Y minus the predicted value for Y. So that's why the residual is 27, 5, negative 23, negative 1, 48, 17, 5, and 15. Okay, so we have 978 minus 963, that's 15. 103 minus 998, that's 5. Right? So that is how you completed the the table. Now, if you are going to graph, this is how it looks like. So this is the enrollment. The scatter plot with the line of best fit suggests that there is a negative correlation between years and enrollment. Okay, this is how it looks like. Now, your residual. So from the residual plot shows the residual randomly distributed above and below the x-axis and somewhat clustered close to the x-axis. The linear model is likely a good fit for the data. Okay, so that is how you analyze your um, residual, and you have to interpret your residual plot. Okay, so this is the enrollment, and then they managed to get what is the best line of fit, and then this is now the residual. When we go over and this one, we plot this together. So you have from year 0, and then that's 27. So from year 0, it's here. So if you go here, that's 27 here. So it's basing it's going from the x upper of x and then the lower of x, right? So that is how you do our analyzing best lines of fit, and also the scatter plot, right? So I want you to work on the assignments that you have in your savas. Thank you guys, and have a good day. Bye bye.